AI patent obviousness, teaching away secondary factors and surprising results. In AI patents, obviousness is the main hurdle. Examiners often say, a skilled person could combine these known pieces. Your job is to show why that combo wasn't actually obvious. Two powerful tools help. Teaching away, prior art discourages your path, and secondary considerations, real-world proof that your idea wasn't obvious. Clear, targeted language turns dry citations into a persuasive story. We'll unpack the phrases, evidence, and structure that move an argument from maybe to persuasive. With concrete examples, you can adapt to model architectures, training strategies, and deployment pipelines. Teaching away means the prior art doesn't just fail to suggest your approach, it discourages it. If earlier papers warn that a method leads to risk, failure, or inferior results, they signal that a skilled practitioner would avoid your path. For AI, that might be a paper stating that joint training, quote, destabilizes convergence, or that sparse attention degrades long-range reasoning. Your argument. When experts are told a technique is problematic, the logical move is to steer clear, not to combine it into the claimed solution. That's classic teaching away. Hunt for explicit negatives. Red flags include words like unsuitable, ineffective, impractical, or unstable. Comparatives matter too. Phrases like preferably avoid, inferior to X, worse than baseline, or suboptimal in production. Conditionals reveal expectations. Would not, should not, fails when, does not scale beyond, or degrades under. In AI papers, look in limitations, ablations, and deployment notes. Collect verbatim sentences. Don't paraphrase. The stronger the discouraging language, the clearer the message. The art told skilled people to go the other way. Be surgical. First, quote exact discouraging phrases from the prior art. Next, link each phrase to your claimed feature. The reference warns that cross-modal pre-training destabilizes gradients, while Claim 1 requires cross-modal pre-training with adaptive clipping. Then explain why a skilled person would steer clear. Adopting a technique expected to fail risks wasted compute and poor metrics. Finally, contrast goals. The prior art seeks stability by reducing coupling. Our solution achieves stability with adaptive controls, enabling the very combination they warned against. That's a clear teaching away narrative. When debate over obviousness is close, secondary considerations, objective real-world indicators, can tip the scale. These include commercial success, tied to the claimed features, long-felt but unmet need now satisfied, industry praise, and even copying by competitors. The key is nexus. Show that the success flows from the claimed invention, not from branding or unrelated features. In AI, this could be rapid adoption of a training recipe uniquely defined in your claims, or benchmark wins credited to your specific architecture tweak. Objective data transforms theory into credible proof. Use verbs that show causation. Performance uplift results from the claimed sparse gating scheduler. Adoption was enabled by the on-device quantization method. Revenue growth is driven by the claimed retraining loop. Anchor assertions with evidence. Dates of release, sales curves, benchmark tables, and citation timelines. Bring in third-party voices, independent reviews, conference awards, and competitor documentation. Avoid vague praise like innovative or state-of-the-art. Be specific. Reduced inference cost by 63% at equal accuracy. Credited to the claimed KV cache policy. Specifics persuade. highlight outcomes that defy prior expectations. Examiners respect surprising improvements, a magnitude jump like 5x training throughput, or a quality jump like materially lower bias at constant accuracy. Emphasize counterintuitive trade-offs, e.g., better accuracy with fewer parameters, or increased robustness with less data via targeted augmentation. Support with controlled comparisons and ablations. Isolate the claimed element, hold others constant, and show the delta. If the art predicted degradation and you demonstrate improvement, that's strong evidence your path wasn't obvious. Build a tight narrative. First, map prior art right pointing arrow teaching away quotes that warned against your path. Second, tie real-world proof right pointing arrow secondary indicia with a clear nexus to the claimed features. Third, frame the surprise. Explain why results contradict the field's expectations. Finally, close with a claim-focused causal story. Because the art discouraged X, skilled workers avoided it. Our claimed Y overcomes the stated risks, producing unexpected Z, as evidenced by adoption and awards directly tied to Y. Precise language plus objective proof wins obviousness battles.